Today we'll be discussing slope change. At the end of the lesson, you'll be able to make transformations from the parent graph and examine the effect of the transformations on the slope and the intercepts. So we make a slope change. This is when the graph of the line is compressed or stretched. So stretching means that it's going away from the axes, and the compression is going toward the axes. So we make that stretch or compress horizontally. It's when our coefficient b is greater than 1, then the graph is compressed toward the y. If the coefficient b is between 0 and 1, so it's a fraction, it means it's being stretched away from the y-axis. So a vertical, notice that our coefficient a is on the outside of the parentheses, and if that's greater than 1, the graph is stretched away from the x. And if a is between 0 and 1, it's being compressed toward the x. So some examples. Graph the functions to determine the effect. Well, the first one, f of x equals x, that's our parent graph, and that's the one going through 0, 0. Our g of x, which means 2 times f of x, if it helps, just think about that being y equals 2x. And you know how to graph that. We just go up 2, starting from 0, 0, and write 1. So you can see the black line is our parent graph, and the red one is that transformation. And see how it's being, the red one is moving away from the x. It's going toward the y, it's moving away from the x. Let's try this one. Again, we have f of x equals x, that's the parent graph. Notice that the 1/2 is on the inside, so think of it reading like that. Y equals 1/2 x, so that means we start at the 0, 0, and go up 1, right 2. See how the blue line is stretched away from the y? All right, so determine if it's a vertical or horizontal stretch or compression. So A, you can see it's a fraction, and it's on the inside. That means it's a horizontal stretch. B is a fraction, but it's on the outside of the parentheses, so that is a vertical compression. C, again, that coefficient is on the outside. It's a whole number this time, so it's a vertical stretch. And the D, the number 4, the coefficient's on the inside, but it's a whole number, so it's a horizontal compression. This time we're given a different line, so not the parent graph, but it's the original graph of 1/3 minus 1. So our first line is g of x equals f3 of x. So notice that 3 is on the inside, so we're going to multiply that 3 just times the 1/3, and then we get 3 times 1/3 is x minus 1. In the second one, notice that the 1/2 is on the inside, which means we just multiply it by the x, and we get 1/6 x minus 1. So the black line is our parent graph, and then see the blue one, see it was a whole number, so that's a horizontal compression, and the green one is a horizontal stretch. All right, say a slightly different line, 1/3 x plus 1. So this time we have the 3 on the outside. So imagine that we're multiplying it by everything, because the 3's on the outside, so we have to use like the distributive property. So 3 times 1/3, and then 3 times 1. Same thing with this one, the 1/2 is on the outside, so we use distributive property. And this is what our graph looks like. Notice that the x-axis didn't change, but the y did. So the black line is our original graph, and the red one is our vertical stretch, and the green one is the vertical compression. All right, so make the translation to the function, write the new equation. So the first one's a horizontal stretch. Notice that the coefficient is on the inside. That means we just multiply the 2 by the 1/2. And the second one, the vertical compression, the 3 is on the outside, so we use distributive property and multiply the 3 times the 2x and the 5. So let's do a little practice. F of 5x. Vertical, horizontal, stretch, or compression. That one is a horizontal compression. 3 f of x, notice the 3 is on the outside, vertical stretch. 1/2 f of x, coefficient's on the outside, but it's a fraction. F of 1/2 x, inside, horizontal stretch. See if we can bring this down here. 1/3 is on the outside, vertical compression. F of 6x, 6 is on the inside, horizontal compression. 7 f of x, 7 is on the outside, vertical stretch. And this last one, f of 1/4 x, inside, horizontal stretch. So a vertical stretch goes which way away from the axis? It goes away from the x-axis. The horizontal compression goes toward which axis? The y.